So, hello everyone. Today we are going the game theory, which is basically used for the quantitative and for decision making. So, for basically, if like we have to- so what student they should make so that they both will make the profit. This is the game theory rules. Let's go uh, further. So now what we are going to see, we are going to see what is game theory, what history of the game theory, and applications of key element of the game theory, what does it comprises of, and what should be the result of these type of answers should be discussed in the last. Nash equilibrium, pure strategies, and mixed strategies, two-player zero-sum games. So, what is game theory? As we know, in strategic games, so what is meant by the strategic games? In the general, like there are many possible situations which may arise in which you have to make the decisions which either benefit of you or either benefit of you and your opponent. So you will both be in the profit. So in strategic games, I can choose strategies that will maximize their return. If I face a game, so I will choose a strategy which will profit me, which will make me in the more profit. That's why we will use which maximize our returns and given the strategies the other agent choose. If other chooses then over them, then makes our profit. And in simple word, it is the mathematics of human interaction. In very simple word is said to be mathematics of human interaction. So where does the history? What's the history of the game? Where does it came and how does it evolve? So basically, Von Neumann wrote a key paper in 1928 about the game theory, not in exactly what two days, but in a simple version of it. Then, in 1944, Theory of Games and Economic Theory is published by the Von Neumann and Morgenstern. And in 1950, Nash. Nash was a person which invent the Nash equilibrium and all the stuff that are more important than in the game theory. In 1994, they got a Nobel Prize in economics for the game theory work. Like it's a better way to it is a very good course for like taking your decisions in such a way that will maximize your profit in real life examples also. Okay, so what's the application of the game theory? Application of game theory can be used in mathematics, CS, like we have read many books, biology, economics, political science, international relations, philosophy, law, sports, game playing, management. All these. Okay, so what's the key element? What does it comprises of? What are the like what are the words which like used in the game code in most way. So players, who are the players who is interacting with one another? What are strategies? What are their options? What are their possibilities to future payoffs? What are their incentives? What will they get? Information. What do they know about the opposite partner of themselves? Rationality. How do they think? Your game. Like what are the type of the game? These are major type of the games which are game theory is one cooperative or non-cooperative, zero sum and non-zero sum. We'll talk them in detail. Simultaneous and sequential, perfect information and imperfect information. When perfect information about your opponent that he is going to do this, and imperfect that you are not confirmed about the finite and finite strategies. Okay, so what are the pure strategies? Pure strategies, let us okay. So in pure strategy, the upper value of the game. The upper value of the game is the minimum of the maximum value of the column. So we will discuss into the next slide that what is meant by the upper value. Upper value is the maximum profit. Like you have no. The upper value means is equal to the like minimum. Suppose you have a column, let's say. Suppose you have this column, then the minimum value in this column, minimum value minus 12, then it will become the upper value of the game. And what's the lower value of the game is the maximum of the. Let's suppose we see this, or we see this. Since 7 here becomes the maximum. So do you realize that the lower value is the maximum of the minimum values in the rows? In the rows, yeah. One thing more that in the rows and in the columns. Okay, so this is let's say A. If A go by one, then we have a ability that he will get 10 points or something. This is a basic simple example to start with. Like what's the mixed strategy? A mixed strategy game exists when there is saddle. Each player then optimize their expected win by determining the percent of time to use each strategy. There are no such strategy that if they take such strategy, they will get profit. So they have to play a mix of strategies to get themselves into the profits. And this is the most important thing. Like when you see in the NAS equilibrium, it is the one of the most important. That you always depends on the other. You don't have a perfect strategies or a perfect something that you will going to do. Okay, so what's the Nash equilibrium? Nash equilibrium is one of the important point uh, game theory. Like a player best strategy is that maximizes that player's payoff. So obviously, if for me, like if I'm choosing strategies, then obviously it will be better for me that if it's pay me more. Basically, if I got more incentives or if I get more profit, then obviously I would prefer that. So that's right. Cash equity. Clear. So like place that strategy that is the maximum payouts. So what's the two player zero sum? So basically penny magic. Let's suppose each of the player has a penny and suppose each of the player has a penny. Then penny is simply you can assume that's fine. So two players must simultaneously choose whether to show head or tail. Right? This person toss the coin and choose whether they want head or tail. Both players knowing the following. Right at the beginning, certain foundation. That's right. Follow that. So if two pennies matches, let's say both head or tail, then player two wins, player one's penny. Then player two will wins, like he will profit. So here and otherwise player one wins, player two winning. So if we see that both head or both tails, so who is in profit? Player two. This is player two and this is player two. So we have written one. It means it is in profit and minus one means it is in loss, obviously, of one penny. That's why here we have written one and here we have written one. What if they doesn't get like head or tail? If they get head and tail, then obviously you will win player one. So in this way, we have described this game. Then what's the business dilemma? So it's basically if there is no communication. Think if it's a better example of that. Let's suppose it's a thing to rob the store or anything. But police don't have a proof. So they take both peoples separately and ask the questions and tell them that and tell each pillar that if you accept that you are going to rob the store, you will get the 0 months prison and if you doesn't, you will get the 12 months prison. So and if you both accept, if they both accept they will get 8 years of prison. If nobody accepts it, they will get free. Then what should be the conditions? So in this way, like there is no option to discuss. So they must take the strategies without the knowledge of what the other pillar is. They have to strategy how knowing what the other pillar is going to do or what he is going to think or he is going to take the strategy. In this way, the prisoner's dilemma works. Brilliant is the dominant strategy, but I'm not necessarily the best one. So in this way, the player choose what the profitable to us, but not for the others. In this way, they both will go to the jail. That's why this is the one of the most important thing which you have to think that we will do the other strategies. So so prisoners should develop. So in this way, the game theory works that at least both should be the profitability. What is the payoff matrix? Like this, what I told you that if we are going to support further there. So if there are two players, one player name is Bill, another one player name is Ted. So let's suppose Bill confess, so he will get if both confesses, both to get 5 years. If Bill not confesses and Ted confess that he is going to pop this fruit, 10 years for Bill and 1 year for Ted. And if Ted confesses, if Ted not confesses and Bill confesses, then 1 year for Bill and 10. And if they both 3 years. So what should be the better option here to so let's see. What's the better option? So let's suppose that let's suppose the police asks the dad. So what's the option to the dad? Confess or not confess? Let's suppose at this point Will confesses. If Will confesses, then we have to see over this row. So what should Ted choose to make his profit? Obviously, Ted will choose this because he will get only 5 years into the prison instead of 10 years. Ted will choose this. If suppose Will not confess it, then what will he choose? Then here we will choose this. Obviously, the this column was there is 1 year for Ted and there is 3 years. Obviously, Ted is always going to choose the first column. And suppose if Dad confesses and Bill have to choose one, then what will Bill choose? Obviously, Bill will choose this. Both get 5 years. And if so Dad doesn't confess, then what will choose? Bill choose the 1 year for Bill. So obviously, in both ways, they are Dad is choosing the first column and Bill is choosing the first row. That's why they both should choose. Both get 5 years. In this way, they both will be the safe. In this way, the prisoner's dilemma works. And same, an example of mix, like we have got about the mixer, is the example of that. That what is B believes one and what is A believes. In this one, it works. What is Nash equilibrium? Nash equilibrium? Yeah, yeah. Yes, so let's now talk about Nash equilibrium. This is first when each player strategy is optimal, like strategy of the other. This is to take the strategy such a way that profit. Second, a player basis with that is study that maximizes best player offer skill. Clear for everyone. That study that it maximizes his or her profits. In the study of the other. So when each player within a team for their strategy and has equilibrium. So like with him, like if suppose Cat and Will can she take the strategy best for her or will take the strategy best for her. In this way, a Nash equilibrium. So how to solve Nash equilibrium? Let's suppose on so in the normal game, let's suppose S1, S2, Sn. These are the these are for every pillar suppose 10 and for and combination of strategy. And these will be the combination like S1 is for one strategy, S2 is for one strategy. There are the possibilities thing. So what so is a Nash equilibrium? If so when it becomes a Nash equilibrium, if both players choose their best strategy and that's become full profitable. So in this way, the Nash equilibrium will occur. So Nash equilibrium. Nash equilibrium, let us talk about Bayesian Nash equilibrium. So Nash equilibrium of the imperfect information. While they have the perfect information, we have just thought about. So Bayesian equilibrium is a set of strategies that each player is playing a pressure. It means that each player is playing the strategies which will gives the best profitable given a particular set of outcome by means we have only a belief about the opponent that he's going to do this. Only a belief, not sure, not even say certainty. Okay, so that's why we say patient magical. That we don't have a certainty about it. It's just a belief or a views about it. So all players have the same prior beliefs, however, when the restriction of nature. It will works on the, for example, uh, all players think out of the player from a particular type is weak. So, like if we have a suppose odd and even, there's a probability of the odd is p, and obviously the sum of the and not odd is one minus p. So this and these are the references which I use while learning. This is a game theory playlist given by the IIT. It is a very good one and very good with his thoughts, I think. And thank